Rational and Irrational Numbers.
Today, we will study about number systems. Let's talk about natural numbers. Counting numbers like 1, 2, 3, 4 are called natural numbers. We denote the collection of natural numbers by n. Whole numbers. All natural numbers together with 0 are called whole numbers. We denote the collection of whole numbers by W. Now comes integers. The negative numbers, the positive numbers, and 0 together form the set of integers. The set of integers is denoted by symbol Z or Z. Now let us see what are rational numbers. A number R is called a rational number if it can be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. Rational numbers include natural numbers, integers, and all the negative and positive fractions. The collection of rational numbers is denoted by a symbol Q. Rational numbers between any two rational numbers. There are infinitely many rational numbers between any two given rational numbers. Now let us take a look at number line, and we will find a few rational numbers between 1 and 2. Now, to find a rational number between 1 and 2, we will add the numbers and find their average. So, 1 plus 2 divided by 2 is 3 upon 2. Next, we will try and find a rational number between 1 and 3 upon 2. So what do? We again plus 1 to 3 upon 2 and divided by 2. And we get 5 upon 4. Let's do this exercise again. Now we will find a rational number between 3 upon 2 and 2. So, let's add 3 upon 2 with 2 and divide it by 2. We get 7 upon 4. It is quite interesting. Let's do it again. Now we will find a rational number between 1 and 5 upon 4. So again, we will add 1 to 5 upon 4, which is divided by 2. And we get 9 upon 8. I'm sure now you must have realized that, in fact, there are infinitely many rational numbers between 1 and 2. So students, in general, there are infinitely many rational numbers between two given rational numbers.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें.
Now we will discuss irrational numbers. A number s is called irrational if it cannot be written in the form p upon q, where p and q are integers and q is not equal to 0. For example, root 2, root 3, root 5, root 6, root 11, pi, or 0.10, 110, 1110, 11110, etc. They are not rational numbers, so they are irrational numbers. Real numbers. The collection of rational numbers and irrational numbers together make up a collection of real numbers. The collection of real numbers is denoted by R. Note: Number 1. Every real number is either rational or irrational. Number 2. Between any two real numbers, there exists an infinite number of real numbers. Number 3. On the number line, each point corresponds to a unique real number. On the other hand, every real number can be represented by a unique point on the number line. That is why we call a number line as a real line also.
N is equal to natural or counting numbers, that is equal to into brace brackets or curly brackets 1, 2, 3 up to infinity, bracket closed. W is equal to whole numbers, meaning the set of whole numbers, that is equal to into brace or curly brackets 0, 1, 2, 3 up to infinity, bracket closed. I is equal to integers, that is a set of integers equals to into brace or curly brackets infinity to -3, -2, -1, 0, 1, 2, 3 and so on up to infinity, bracket closed. Now let us see what are rational numbers. Definition is as follows: if p and q are integers where q is not equal to 0, then a number denoted by p upon q with the property that p upon q into q is equal to q into p upon q is equal to p is called a rational number. Rational number is indicated by capital Q. Q is equal to into brace brackets or curly brackets p upon q divided by p, where q is a part of I, that is an integer, and q is not equal to 0. Properties of a rational number. addition, subtraction, multiplication and division except with the number 0 is possible in the sets of rational numbers. If a, b and c are any rational numbers, then a plus b is equal to b plus a and a into b is equal to b into a. For example, 2 plus 3 is equal to 5 and 3 plus 2 is also equal to 5. Similarly, 2 into 3 is equal to 6 and 3 into 2 is also equal to 6. Number 2, in bracket a plus b bracket closed plus c is equal to a plus into bracket b plus c bracket closed and into bracket a into b bracket closed into c is equal to a into bracket b into c bracket closed. Number 3, the rational number 0 has the property that a plus 0 is equal to a and that is equal to 0 plus a. For example, 2 plus 0 is equal to 2, which is equal to 0 plus 2. Number 4, for each rational number a, there is a rational number minus a with the property such that a plus into bracket minus a bracket closed is equal to into bracket minus a bracket closed plus a, that is equal to 0. Number 5, the rational number 1 has the property such that a into 1 is equal to a and 1 into a is also equal to a. Therefore, any number multiplied by 1, we get the answer is the same number. Number 6, for each rational number a where a is not equal to 0, there is a rational number 1 upon a such that a into 1 upon a is equal to 1, that is equal to 1 upon a into a. Number 7, a into bracket b plus c bracket closed is equal to a into b, that is ab, plus a into c, that is ac, and a plus b into brackets multiplied by c is equal to a into c, that is ac, plus b into c, that is bc. Decimal representation of rational number. Number 1, any rational number can be written in the recurring form in decimal method. For example, 1 upon 2 is equal to 1 divided by 2, that is 0.5. This can be written as 0.5000 up to infinity. Similarly, 2 upon 5 or 2 divided by 5 is equal to 0.4, that is equal to 0.4000 up to infinity. Number 2, in decimal form, if we get a non-terminating quotient, then that method is known as recurring decimal form. The recurring digits from the recurring group are indicated by putting a dot above the first and the last of them or a line segment above the recurring group. Now let us see irrational number. Each decimal expression of the non-terminating, non-recurring type represents a number which is called as an irrational number. When decimal form is infinite but not recurring, then it is known as irrational number. For example, 8.33044055066077 up to infinity. Here there is no recurring number, therefore it is a rational number. Another example, 0.1010010001000 up to infinity. number pi. Definition: ratio of perimeter of the circle and diameter of the circle is constant and is known as pi. Perimeter of circle is equal to 2 pi r and the diameter is 2r. If we take the ratio of perimeter and diameter, 2 pi r upon 2r is equal to pi. Therefore, pi is a constant. Also, pi is an irrational number. The assumed value of pi is 22 divided by 7 or 22 upon 7, that is equal to 3.1428. Number line: all rational numbers and irrational numbers can be represented on the number line. We call the number line as real number line. The number related to the point on the number line is called the coordinate of that point. For example, L is the number line. Center of L is 0. To the right hand side of 0 are the numbers 1, 2, 3. On the left hand side of 0 are -1, -2 and -3. The coordinate of O is 0 and this is the point of origin.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें.
Real number, rational numbers and irrational numbers taken together form the set of real numbers, which is denoted by capital R. N, or set of natural numbers, is a subset of W, that is set of whole numbers. W is a subset of I, that is the set of integers. I is the subset of Q, that is the set of rational numbers, and Q is the subset of R, that is the set of real numbers. Now let us see the properties of order relation on R. For the real numbers A, B and C, number 1, one and only one of the following relations must hold: A is greater than B, or A is less than B, or A is equal to B. Number 2, if A is smaller than B and B is smaller than C, then A is smaller than C. Number 3, if A is smaller than B, then A plus C is smaller than B plus C. Number 4, if A is smaller than B, then 1. A into C is smaller than B into C if C is greater than 0. Number 2, A into C is greater than B into C if C is less than 0. And number 3, A into C is equal to B into C if C is equal to 0. Now, absolute value or modulus. Number 1, the absolute value of a real positive number is positive. For example, absolute value of 3 is equal to 3. Number 2, the absolute value of a negative real number is its opposite number. For example, absolute value of -3 is equal to 3. Number 3, the absolute value of 0 is 0, that is, absolute value of 0 is equal to 0. Number 4, the absolute value of a negative real number is its opposite number, that is, absolute value of A is equal to absolute value of -A.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें. ऐसे ही और एजुकेशनल वीडियोस देखने के लिए हमारे चैनल होम रिवाइज को सब्सक्राइब करें.